water and a laser beam. Offer better heat insulation properties and more flexibility for use in inner room. Diameter and length of the tube. Use, for example, aluminum, highly reflective aluminum. Hey, what's up everyone? You are watching Easy Tech channel, the place where you can find interesting things. I'm Mehram Inbashi, and whether you are here for the first time or you are already part of the squad, get ready because we are about to dive into something epic today. Before we jump in, make sure to hit that subscribe button and smash the like button if you are ready for some next level content. Alright, let's get straight into it. Today we are talking about optical pipes. So buckle up and let's go. At first, we investigate the optical behavior of materials. Here you can see a bowl of water and a laser beam. When the light incident normally 90 degrees on the surface, then there is no bending of the ray of light. When a ray of light travels from a rarer medium to a denser medium, it bends toward the normal. When a ray of light travels from a denser medium to a rarer medium, it bends away from the normal, as you can see. Now you can see refracted ray, reflected ray, and incident ray. The angle of incidence, for which the angle of refraction is 90 degrees, is called the critical angle. And the angle of incidence is more than the critical angle, the total light rays will be reflected back into the same medium, and you can see total internal reflection also. Now you can see the angle of incidence is less than the critical angle. The light rays will get refracted to the rarer medium. Part 2. In part 2, we want to investigate the light pipes, structure, and the mechanism. At first, we define a light tube that's known as a solar pipes, tubular skylight or sun tunnels, daylighting devices, sun pipes, sunscopes, or daylight pipe are structures that transmit or distribute natural or artificial light for the purpose of illumination. There are two broad categories: hollow structure that contains the light with reflective surface, and the transparent solid that contains the light by total internal reflection. A tube lined with highly reflective material leads the light rays through a building starting from an entrance point located on its roof or one of its outer walls. The entrance point usually comprises a dome that collecting and reflecting as much sunlight as possible into the tube. At the end point, a diffuser spreads the light into the room. And also you can use a heliostat, can be set to capture moonlight also at the night. Solar light pipes, compared to conventional skylights and other windows, offer better heat insulation properties and more flexibility for use in inner rooms, but less visual contact with the external environment. In the context of seasonal affective disorder, it may be worth considering that an additional installation of light tubes increases the amount of natural daily light exposure. Light tubes can be combined with artificial light as a hybrid setup. Three key factors for design are important that are diameter and length of the tube, angle of incidence, and third is material of tube. In part 3, I would like to talk about the installation of light pipes. At first, we can see the materials that used for installation. The first is high impact acrylic dome. The second is flashing. Third is highly reflective light pipe. and the fourth is decorative trim ring and diffuser, as you can see. Here we use a cutter to make a circular cut in the ceiling of the house. Now we cleanse the inside of the ceiling. We use a laser meter to mark the path for the light tube installation. Now we shape flat, highly reflective sheets into a tube with the desired diameter and secure it with adhesive. Now we attach the diffuser vent to it and drill to it. We install the light pipe in the place that we prepared before. Now we connect the decorative trim ring and diffuser to the light pipe. Now we connect the flashing and high impact acrylic dome as an entrance for input of light. Now you can see the results that very effective for brightening, lightening the house without any electricity. Now we investigate the energy saving estimation. Here we must consider some equation. The solar irradiance, we can define it as I, that is equal to P divided by A. P is solar power and A is area. And we can define light transmission efficiency as eta, that is equal to P out divided by P in. The energy saving from solar tubes, or E saved, it's equal to P light multiplied by time of use multiplied to efficiency. E saved is energy saving, and the unit is kilowatt hour, and the P light is power required by artificial lightning, and time of use, the time of the lighting is used, and efficiency is efficiency of solar tube or solar pipe system. And for example, let's calculate for a power of 100 watts and in the 5 hours time with the efficiency of 0.7. The E saved is equal to 100 watt multiplied to 5 hours multiplied to 0.7. It's equal to 350 watt hour per day, and for 3 days you can see it is equal to 10.5 kilowatt hour, and it is a massive energy saving. Okay, in part 4 I would like to talk about the simulation of light pipe in a home. Okay, you can see the parameters here that I define R pipe, L1, RB1, and you can see all of them. I just used this parameter into cylinder 1, as you can see in radius and height, and torus 1, cylinder 2, torus 2, and cylinder 3. You can see all of them. I scaled all of them to 0.5 as a factor, and I use union. I import the desired house. You can import from your SolidWorks project or other software project. as STL file or as MPH-bin. I move it and you can see the light pipe with the curvature structure are inserted into the home. I add the PMMA as a material of that. You can use, for example, aluminum, highly reflective aluminum, or acrylic, or anything else. I use a geometrical optics with a maximum number of secondary rays of 1000 and refractive index of 1 for air, and medium properties from material and material discontinuity as threshold intensity of 1 millivolt per square meter and threshold power of 1 microvolt watt, and the wall is considered freeze. I choose array properties at the vacuum wavelengths of 660 nanometer and the release from grid of 2000 and cone axis in Z direction and the cone angle of pi divided by 12 and total source power of 1 watt. Here I provide a mesh with the size 1 and free tetrahedral, as you can see, and I use parametric sweep by ray tracing. After computation, you can see the results, that how much the ray is transmitted to home and how much of that is reflected, and the transmission versus the radius of curvature. Okay, I hope you enjoyed this video, and I hope you subscribe to my channel, share my channel to your friends, like my videos, see my videos many times, and please don't download them, just see it in YouTube and help me to monetize as soon as possible. Take care, have a good time, goodbye.